candle hot air balloon is small-scale demonstrations of the principles of buoyancy and thermodynamics, inspired by the workings of full-size hot air balloons. The design is rooted in Archimedes' principle, which states that an object in fluid, including air, experiences an upward buoyant force equal to the weight of this space fluid. This principle, combined with the behavior of ideal gases, governs how the balloon floats and falls. The concept of our chosen project design, which is candle hot air balloon, operates based on fundamental principle of thermodynamics, particularly the first law of thermodynamics, the ideal gas law, and also buoyancy. The design functions as an open system with ideal gas, meaning it exchanges both energy, which is heat, and also mass, which is air with its surroundings. This contrasts with closed systems, which only allow energy transfer, and isolated systems, which do not exchange energy or mass. The first law of thermodynamics states that delta U equals to Q minus W, where delta U is the change in internal energy of the system, which is in this case is hot air inside the balloon. Q is the heat added to the system from the candle, and W is the work done by the system, which is expansion of air and lift. While for the ideal gas law and thermal expansion, the behavior of air inside the balloon follows the ideal gas law, which is PV equals to nRT, where P equals to pressure that remains nearly constant since the balloon is open at the bottom, V equals to volume that will increases as air expands, N equals to number of mole of gas that air may enter and leave the balloon, R is the universal gas constant, and T equals to temperature that may increases due to the candle's heat.
So now I will explain to you about some of the real-world application that is related to our project, which is hot air balloon. So the first application that I want to show to you is solar chimney. So this is how it looks like. So basically, solar chimney is a type of passive solar heating and cooling system that used to regulate the temperature of a building as well as providing ventilation. In a solar chimney, the air inside the chimney is heated by sunlight and then absorbed by its dark surface. As the air warms, it becomes less dense and creating an upward draft. The momentum of air drives ventilation and then it cools the building depending on the setup. So the next application is smoke from burnt house. So you guys might ever heard that when someone is trapped in burnt house, the way to escape is by crawling to avoid the smoke. This is because the smoke is hotter than the surrounding air, which is it is less dense than the cool air. Since there's a difference between this hot air and cool air, it creates a buoyant force which causes the heated air and smoke to rise. The upward motion of this smoke is added of convection current, which is a process when the heated air rises and the cooled air will rush in to take its place. So what we can conclude here is the key connection that we can see from this real-world application and the hot air balloon is all the system leverage the fact that warm air will rise due to its lower density compared to cooler air. That's all from me. Thank you.
Another important area is internal combustion engines. These engines, found in many vehicles, operate through a cycle of intake, compression, combustion, and exhaust. The first law is central here. The combustion of fuel adds heat to the system, increasing the internal energy of the gases. This high pressure, high temperature gas that expands doing work on a piston. This expansion is governed by the ideal gas law, which relates to the pressure, volume, and temperature of the gas. The efficiency of this energy conversion is key concern in engine design and it's limited by the second law of thermodynamics, which dictates that not all heat energy can be converted into work. Some is always lost as waste heat. And let's consider also refrigeration. Refrigerators and air conditioners move heat from a cold area to hot area, which might seem counterintuitive. This process relies on the principle of thermodynamics. A refrigerant, a fluid with specific thermodynamic properties, is cycled through evaporation and condensation. When the refrigerant evaporates, it absorbs heat from its surrounding, cooling them. This is a phase change that requires energy. The refrigerant is then compressed, which increases its temperature, and its releases heat when it condenses. This process involves heat transfer, change in internal energy, and work being done on the system, all described by the first law of thermodynamics. The efficiency of the refrigeration system is also constrained by the second law, which dictates the minimum amount of work required to transfer heat between two temperatures. So, in summary, while diverse, all are fundamentally governed by the first law, the ideal gas law, and the buoyancy. Understanding these principles allows us to explain and engineer a wide range of important phenomena and technologies.
Hey everyone, today we are making a DIY hot air balloon. Let's get started by explaining the item we have. We have a 9x9 cardboard paper which will serve as the base for our candle, sellotape, 5 candle, lighter, a straw, bag plastic, and a scissor. For the first step, we will cut the straw into 8 parts. Now we have 8 parts of straw. And then we attach them around the plastic bag to add some width and structure. It should be look like this and repeat until finish. Now the straw are in place. We can see the plastic bag act as the balloon itself. So let's move on to the next step. Take the candle and place them on the cardboard paper. It should be like this. We have done with our hot air balloon. Let's go and see how it works.